and obviously to Sri Dayashankar Babu for giving such an opportunities to me. And I'm just going to the, before starting to the things, I have to state one thing, that I'll try to discuss with you very basic things of sampling theory. And it is not possible for me to isolate mathematical part completely. So some mathematical estimations are still there, but I try my level best to minimize such kinds of things, because it is a statistical kinds of things and where the mathematical illustrations are very significant. So why? Without considering such estimation, statistical kind of things, it is not statistical estimations basically. It is not possible to get the essence of sampling. So I know it is a blended platform of versatile persons from different sections. So I will try my level best to minimize such kinds of things like mathematical reductions of this. Okay, so I'll go to the presentation.
Sir, PPT open করেছেন?
Yes. Now it is visible.
No, right. Yes, sir.
Okay. I just for some that is reason I just off my video because my signal strength is not very much good. So now the PPT is visible to all.
Yes, sir.
Okay. And I am perfectly audible. No? It is clear to all my voice?
Yes, sir.
Okay. Yes, sir. So the discussion area is sampling theory and numerous government. If you have any questions, you can stop me and ask me. Okay, if any problems or any questions regarding the understanding, you can stop me and ask me. Otherwise, at the end, we also can discuss. And if any problem like that is not listening me, Dayashankar Babu, my mobile is on, so you can contact with me.
Sure, sir.
Okay. So in the discussion, that is in different government organizations, researcher, sociologists, and business, we found that we conduct surveys, that is to catch some certain specific questions which cannot be obtained merely through laboratory experiments or simply use economic, mathematical or statistical formulation. For example, suppose one may interested to get the information regarding the proportion of unemployed people. Those who are unemployed are also below the poverty line, and the extent of, for example, anyone other can want to know that is what is the extent of child labor in a certain locality. So it is very important for us, that is to make a proper planning, proper statistical that is designing. So to get the answer of such questions, researchers we do different kind of things, that is surveys over the people of the locality very often. And such surveys should be conducted in such a way that the result of the surveys can be interpreted objectively in terms of something in statistics. It is known as probability. That means how much it is probable. I am not going to the definition of probability. I just for those from not the statistical or economics or mathematics background, probability that means making something uncertainty into some certainty by predicting its values. That kinds of thing. That is one definition. That is, you are not making yourself puzzle without that. I don't know the probability kinds of things. So drawing inference about populations on the basis of sample, we are going to drawing inference about the people. And since the total population, study of total population is not possible for us, so a part of the population that is called a sample is a natural instinct of us. That is, we are going to talk about. That is a small part of the populations. So surveys should be conducted, and in such a way that the inferences relating to the population should have some valid statistical background. So to achieve such valid statistical background or the statistical inferences, one needs to select samples by using that is suitable sampling procedure. That is the word. That is a suitable sampling procedure. Not every sample is suitable everywhere. So why we have to go? We have to know what is sampling, this kind of things, because everyone in this platform are related to some extent in some research. So there may be quantitative, there may be qualitative, that may be descriptive, everyone. But you have to know, that is, in case of descriptive statistics, suppose you are working on some reviews of literature on history. So suppose you are doing some epidemiological historical disease that is occurring in 1910s or 1920s in this period. So to do this, you have to go through the proper sampling procedure. That is, which article you have to consider, which article is not, and there must be some scientific basis for that. So why the suitable sampling procedure is an important one. And we discussed the various methods of sample selection procedure, like data collections, that is methods of data analysis, and the applications under various circumstances. And these are the important. So I'm writing here the different phases of research, and the red one is the important here, and we are discussing about everything about that red one. So population is what? Population is an aggregate or collective form of elements or objects in a particular region or a particular point of time. And it is often, you may consider this as a subject of the study. That is the population. So population is the total thing, and population, each element within the population is called unit. In statistical language, we call it element or unit. Suppose for example, we want to study the health-seeking behavior of, I give this example earlier. That is, suppose here we are wanting to know the health-seeking behavior of Baul Fakir in Birbhum during pre-COVID situation. That is during 2018 or 19, these kinds of situations. So the collection of individual under this category of people who are under this Baul Fakir, that is suppose male or female or child or adult, that is residing in Birbhum, will be termed as the population. So each individuals that is called an unit. So it is clear to you that all individual in Birbhum district is not the population, because we are concentrating on a specific race like Baul Fakir. So among the people of Birbhum, there is a clear compartmentalization between common people and Baul Fakir group. Baul Fakir group is your population. So sometimes such compartmentalization is not visible. Such type of compartmentalization is not visible. For example, we consider the air pollution in a certain region. Suppose someone is working, people from geography or climatology, they are working on air pollution. So the air under the considerations constitute the population, but we cannot divide it into the identifiable parts or elements. So these populations, that is air populations, you cannot divide. That is, what is the air populations of Calcutta and what is the air population of Shodhpur, what is the air population of Naihati. You cannot define by such a way. So such populations which cannot be separated in terms of some geographic boundary or topographic locations, such population is called continuous population. It may be finite or infinite. So populations is it is not your that is we cannot define that everywhere the population is always a finite number. A finite population is collection of finite number of identifiable elements, where the total number of elements, for example, in case of population, you find here I identified the population unit always identified by this symbol in statistics, that is capital N, and that refers to the size of the population. So students, just 1 minute. For example, students in a class, tiger in a national park, the household in a certain locality are the examples of finite population. And as the units are identifiable by the finite numbers. In the case of air pollutions or this kind of things, that is this n tends to infinite. So here it is considered infinite population. This size of population may be known by some. So size of the population may be known or unknown to us before a survey. It may be unknown. It is not required when we are going to sampling. It is not required. It is not very important to us that to know the perfect size of the population. It can be something like we may predict. It may be like this. It is not very important for us in case of sampling to know what is the size, what is the perfect size. But suppose it is also important that in a Birbhum, if the number of the Baul folk is, suppose actually it is 10,000, but you assume it is now near about 100. That is also not expected. So sometimes surveys are conducted to determine this population size. That is from some sample we may I make some ideas regarding the what is the actual size of the population. That is also another part of the sampling. For example, you know that kind of, I just forgot the name, though those who are migrated from that is Burma or these kind of things, and they are identified as some in Bangladesh and then from Bangladesh to India, and that is the illegal immigrants. Illegal immigrants cannot be perfectly identified in terms of sampling purposes. So complete enumeration, complete count of the population is called, when we are dealing with the total populations, that is known as complete enumeration, and that is called census. In case of census, every 10 years occurring in our country, that is every individual's informations will be they may actually recorded into the census table, and the observations of the sampling units in the populations are collected also in the same census. So census is doing the same kind of work what we are doing in sampling. It is a small part. So, but census is a time unit, that is no one individual or unit cannot be deducted. So, this is the basic ideas of population and sampling. That is what is the population and what is sampling. So next we go to the thing like sampling frame. That is what is sampling frame. It is the list of all units of population with proper identification. So we are dealing with some finite population. Suppose we are dealing with some finite. Suppose you interested regarding some socioeconomic survey and you are going towards a village, and in the village informations regarding some basic informations regarding each and every individuals are there. So that is called sampling frame. So your frame is this. That is suppose capital N is the population size. So U1 is some basic character of an individual, first individual. U2 is the basic character of second individual, and by this so on. U capital N, that is the informations regarding the nth individual, nth household. Suppose it is based on households. Suppose we are not on individual, we are interested in households, because in villages they are located there in terms of the households. So another example, that is residents of a city area, may be listed in more than one frame. For example, automobile registration, as well as telephone directory. These kind of things are actually the sampling frame, from where you can, in case of city, you can consider these kinds of things like telephone directory or automobile registrations list on as per your survey needs. That is what you want to know. So these are basic material of conducting a survey. So sampling frame must be complete, up to date, and free from duplications. There is no duplications or omissions are there. This is the first requirement, and we must be careful about this. And for simplicity, suppose we may consider the sampling this unit identified as in this way. That is I is equal to 1 to n. So I think it is a particular unit. It may be household, it may be the individual, anything, or it may be suppose you are working on some motor vehicles, it may be the particular number of the car. So there are two possible ways to ensure the selected sample is representative. And first one is random sample or probability sample. This is a random sample, or its another name is probability sample. That means what? That means there are, suppose you found 200 households. So in the selection of units in the sample, that means which household you have to choose in your sample as a representative of that villages or that area. So population is governed by some law of chance of probability. That is, suppose there are 100 households are there. So which households you have to choose? So random sample means each and every households have some specific probability to come into in your sample. That is, you have to choose that sample, or you have to not choose that sample. So such probability, this is a very, very important sense. Such probability is constant or equal among the all households, may not be equal. So there are two types. I will come later. What are the types of random sample and this? So random means in statistics or mathematics, we means random means that is which is beyond control of anything. When it is beyond control of anything, there must be in statistical language we say that it is random when I attach the probability term with it. A thing is a random when I attach the probability term with it. So probability of selection of unit may be equal as well as unequal. This is the thing of random sample. And another process is there, that is the non-random sample. That is, it is a selection of units of the sample from the population is not governed by any probability laws. So I am not saying that non-random sampling is something unscientific in compared to, but it is true. It is really so. So if you always try to prefer to, but there are different purposes of the sampling in case of study like sociology or anthropology, these kind of subjects. So they always, they sometimes go through that non-random as per their purpose. So it is not saying that it is always good to choose the random sample, but in case of random sample, there are some scientific validity. But in case of non-random sample, there may not always a scientific kind of things. So these are the basic two divisions. One is random sample and one is non-random samples in case of sampling. So the next question is why sampling? That is very important. You know, that is sampling is sometimes cost of the certain factors. We do not get the complete enumeration, because if you surveyed each and every households of the villages, it will take time. It is not possible to cover the villages in 1 or 2 days. It may be require 5, 6 days, and each and every day, if you are not staying there, each and every day you have to spend time, you have to spend cost to go there. So there is a cost. So there is a cost of there, and in that case, considering such cost not only means monetary cost means time cost also. It included the time cost, others cost also. So, considering this cost factor, the sampling saves the cost as well as time. So, why we are going to sampling? So, we have to remind the scientific background of the sampling. So, what is such scientific background? That is the sample. You do the sampling, you recover is your time cost, you recover your monetary cost. You can, you're not recovering, you just curtail down your monetary cost or time cost. But the factor is that what sample you choose, that must be a true representative of the population. That means, suppose there are 100 households and you choose 10 households. So from the character of these 10 households, in what angle you have to discuss your research ideas, that can be encompasses these 100 individuals. That means it can be extended for these 100 individuals. That is the true representative sense of the populations. So that means, starting sample, you can make some ideas about the population character. This is the thing. That is, population have some character. Character means what? Character means that is the variable. Suppose, for example, someone is doing some demographic work, that is age, sex, caste, religion, these kinds of things. You know everyone. So why I am giving the demo. So these are called, each and one is called a variable. So these variables are called the population character. So you choose, suppose there are 100 households, and your variable of thing is age. So if you are interested, suppose for example the average age. What is the average age of the households member in the villages? So you choose the 10 households. Now from these 10 households, what is the average age? If it is found, suppose other persons who is doing the census in that villages and found the average age is very much different from you. So then your sample is not a true representative. That is what we are doing in sample. That is, make some ideas about the population character. The sampling going to comment from the knowledge. What is sampling? That is, sampling is going to comment about the knowledge of a part. That is, we are going to comment about the whole of the totality. That is, from the knowledge of a part, we are going to predict, we are going to comment about the totality. This is the thing. So what are the advantages? And disadvantages are also there. So advantages is one already discussed. That is sampling involves the collection of data of smaller number of units in comparison to complete enumeration or census kind of study. So the cost involved in collection is reduced. Further, additional information can be obtained at little cost in comparison to conducting a separate survey. For example, when an interviewer, suppose, is collecting information on health conditions, then he or she can ask some question on health practices. This will provide additional information on health services, and the cost involved will be much less than conducting the entirely new survey in health practices. But in case of census, what they are doing, that is, they have some particular typical questionnaires. Behind that, after that, they are not asking anything. So this is the limitation in terms of the census kind of study. Second thing is organizations of the work. Organization is what? That is, it is easy to manage the collection of smaller number of units than all units of which is done in the census. For example, suppose in order to draw a representative sample from a state, it is easier to manage small samples from every city or every villages than drawing the sample from the whole state at a time. And that is what we are doing in case of producing our human development report of West Bengal, or it may be for Birbhum, or it may be for Purulia, these kinds of districts. So this ultimately result is more accuracy in statistical inferences because it is betterly organized. that provides better data. In turn, that is, improved statistical inferences are obtained. Third thing is the greater accuracy, that is the persons which is involved in collection of data are trained personnel. I'm not saying that in case of census they are not trained, they are also trained. But just consider that a target to an individual you are given to collect the data from 10 individuals, and the same target is given to the same individual to collect the data of 1,000 individuals. So there is something like we are human, so the data accuracy is questionable in case of census kind of things. And fourth one is we can quickly summarize the thing, that is sampling. We can quickly summarize the results. For example, forecasting of crop productions, if you consider, that can be done quickly on the basis of sample of data, then collected first all informations. So you can quickly summarize, because in case of census it will take so much time. And the fifth one is the feasibility, that is conducting an experiment in some smaller number of units, particularly when the units are destroyed, is more feasible. For example, in case of medical experiment, if it is feasible for use to large large number of individuals, then the biological experiments, they make such experiment on few number of animals. They are not make the experiment for every individuals. So these are the standpoints why we are using the sampling. So next this is a that is different types of surveys are there, and the surveys are what, that is these are the secondary data source also to you, those who are working. There is a demographic survey, and the name of the DHS, that is Demographic and Health Survey. This is the largest organization of the world, established in US, and that is they collect the demographic data of each and every country, and from where the researchers take the data set and working. These surveys are conducted to collect the demographic data. For example, household surveys, family size, number of males in the families, females in the families. So such surveys are useful in policy formulations for any city or any state or country, because IIPS, in International Institute of Population Study, which is located in Mumbai, they are acting as a hand of this DHS, that is Demographic and Health Survey. So this demographic for Indian unit, this is the unit of India. Similar unit is exist in Pakistan. Similar unit is exist in Sri Lanka and Bangladesh. These kinds of things are there. So educational survey, these surveys are conducted to collect the educational data. That is those who are making doing the research over the education. That is how many children are there, go to school, how many persons are graduates. Such surveys are conducted to examine the educational program and colleges, how they are running successfully. Generally, the things like midday meal or the things like ICDS are also included over this. And the third one is the economic survey. This survey is basically to collect the economic data. That is, for example, export, import, GDP, industrial production, consumer expenditure, and so on. So from this economic survey data, we are actually constructing indexes to consider the growth of a particular sector of the economy. Employment survey is also there. This survey is conducted to collect the employment-related data and employment rate, labor conditions, wages, that is in a city or in a country. These are dealing with the employment surveys. Health nutrition survey, this is another survey. WHO and UNICEF are doing this. Survey are conducted in cities and related to health and nutrition issues. ICMR in our country also doing these kinds of things. Agricultural survey, and also the Indian Council of Agricultural Research, and the name, that is they are doing these kinds of agriculture related data estimates. And for example, acreage and production of crops, livestock, fisheries, pesticides use. These are the facts included in. And the marketing survey, these surveys are conducted to collect the data related to marketing. This conducts in major companies, manufacturers, that is such kind of things. Election survey, you are familiar with the AC Nielsen or these kinds of names during the election. So they are doing the election surveys. And there is also campus survey. and these are the educational institutions are there. So so each of these surveys have some that objective. There is the what are the steps of such survey. I'm going to the specifically that means I'm concentrating on a particular sample. That is what are the broad steps. The steps are these are the objectives of the survey. That is objective of the survey is to clearly defined. It must be well defined and well understood by the persons planning to conduct this kind of survey. So it is expected from the statistician to be well versed with the issues of addressed in consultation with the person who wants to get the survey conducted. In case of it may be complex also. In case of complex kinds of survey, there is sometimes the objective is forgotten. The data is collected on the issues which are far away from the objectives. If this is happening, then the objective is not actually targeted by that kind of survey. Second thing is population to be sampled. There is on the basis of that objectives of the survey. That is, we have to decide which are the populations from where we get the informations. For example, population of farmers is to be sampled from agricultural survey, whereas the population of patients to be sampled from medical facility or health survey. Next thing, data to be collected. It is important to decide which data are relevant and fulfilling the objectives, that is objectives of the survey, without omitting any essential data. So then the degree of precision is very important. That is for the result, any sample survey are always subject to some uncertainty. So some uncertainty can be reduced. That means you may not get the proper answer to your questions, and to get such proper answers, what the person that is actually doing in case of anthropological survey. What they're doing in some studies, I found that in anthropology they're targeting a particular one in one household, and they suppose they study on some their behavioristic pattern. That is in case of behavioral study. So they actually interact with them over a month, even over 2-3 months. They're interacting with that particular households, and from there what they are doing, they are trying to reduce the degree of precision. That means going towards the correct things, going to collect the correct kind of informations from these things. And number 5 is the method of measurement. That is choice of measuring instruments, and the methods of measure the data from the population needs to be specified very clearly. For example, the data has to be collected, suppose through interview or questionnaire or personal visits, or suppose focus group of discussions. So any form in which the data are recorded, so that the data can be transferred into some mechanical equipments. That means we can copying the data in the form of data summary in computer or this. The frame is there, and I'm discussing already about the sampling frame that must be clearly specified. That is, population is divided into different sampling units, and then after doing this, we are going to select the sample. That is, the size of the sample need to be specified for given sampling. And this helps in determining and comparing the relative cost and time in different sampling plans. The method and plan that is for such purposes, for example, drawing the representative sample, should be detailed. Then pre-test, that is advised to try the questionnaire and field methods on a small scale. That is, we are making some pre-test method. That is, before going to the final interview, we just make some mock interview. That is the pre-test. And the organization of the field work next. That is how to conduct the survey, how to handle the business administrative issues. That is proper training of the surveyors, procedures, plans, handling of kind of thing like non-response and missing observations. So this you have to organize regarding this, because these are always frequent in your interactions. So the procedure for early checking of the quality of returns should be prescribed, and it should be clarified how to handle the situation when the respondent is not available. So before the last, that is the summary and analysis of data. It can be noted on the basis of the objective of the data, that is the suitable statistical tool, answer the relevant questions. And in order to use that statistical tool, there is a valid data set is required, and that dictates the choice of response. These kind of things are there. There is a summary and information gained for future surveys. That means when you are doing a survey, you can also notate the things, or this is very important. That is, in future, if anyone is coming into this field for some kind of work, then you can make some advanced takes for him or her. That is it will supply various type of prior informations. For example, regarding the different statistical units about that particular sampling field. For example, what is the particular units? This may be the mean, this may be the variance, this may be the nature of variability, this may be the cost involved. So this will help us. So these are the steps we have to follow when we are going to making some survey. So now the important thing is parameter and parameter space. So suppose we are involved in such kinds of survey, and everyone have some research objectives. So he or she is very much careful about the variables which are influencing the thing. So for a given population, suppose we define the population as U earlier, and we are interested in studying certain characteristics of it, and such characteristics is known as a study variable. That means which variable, that means suppose you are going to, I'm giving one example, you are going to know what is the pattern of occupational diversity. That means what is happening, you found that in West Bengal there are so many dole-based programs are running, and the government also encouraged these kinds of program, and the peoples are continuously moving towards those dole centers from where the things are distributed. So considering such kind of things, it is not a very good symbol for any state. And that is peoples are moving there very rapidly, and whether they have to put their name in the list, these kinds of things. So this is not a very good scenario in terms of economic well-being or in terms of social well-being. So under considering such problem, one may consider that what is the pattern of occupational diversity. That is the best variable. What is occupational diversity? That means one person is suppose working, his major profession is agricultural labor, suppose. Now it is within the daytimes. Now whether the same person is pulling a rickshaw in evening, whether the same person is making some bidi in his house, that is the occupational diversity. That means concentration of one individual in many such professions. When it is happening, it is only happen when his food is not secure, when he is not stable in the food supply senses. So he becomes heavily engaged in other professions also. So such characters you have to identify according to your research, and these are the study variables. So when you're considering a population, for example, students in certain class, it may be anyone may be interested to know what is his age, height, racial group, economic condition, marks in different subjects, and so forth. So each of these variables, like what I was saying earlier, is called study variable. And this is identified in statistics. This study variable is identified in the form of y. Why it is I for a particular student. If I is 1, this is for the one students, or one, if it may not be an educational things, it is the first individual. I2 for the second individual, whatever may be your sample size, from where you can determine I. So yi with the value of the study variable y for the ith unit of population, which is identified as U, and which is generally not known before the survey. So when you are going to do a survey, that there is a population, and each and every population units have some particular character like y. So this is the character vector or character variable that is consist of capital N number of population size. So the set of all possible values of the vector y, it is in mathematical language, it is called in dimensional Euclidean space. So it is not, those who are not in mathematics, it is not very important thing. You have to know that there are n number of individual characteristics are there, and these characteristics are identified as y1, y2, y3, dot 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 yi, and dot 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 yn. That means n number of individuals information is there. So suppose you are find out, you are interested, what is my total of this? That is the population total. That is when you make the total of this, that is adding all these values, that is identified as population total of that particular static variable y. You may calculate the what is the average, that is what is the average value of y, and that is a simple thing is that is 1 by n into summation of yi, and that is the population mean. You may calculate the population variance. This is the formula of variance is written there. That is, you write it as sigma y square or sy square. That is 1 by n summation of yi minus mean, population mean, its square, and sum of this. And one may find out the coefficient of variance, that is the CV, and that is population variance. What you found, it's root over, that means the standard deviations divided by the mean, and that is the population variance. So these things are related with the population. Same thing when we are, these are the parameter. So mind the parameter. Parameter is a character of population. So when I am going to choose a sample, then suppose I choose the number 2, y2, suppose y2 is coming to my sample. So that y2, when it is into my sample, it is not called the parameter. Then its name changes. We call it statistic. A statistic, not statistics. It is called statistic. So, or the estimate. That is from where we are going to estimate the population and the sample character. And now the question comes, before going to that kind of complexity, the question comes, that is again I am going back. Why this is sampling? This is a sense, very important thing. That is population parameter identification is a significant task of the researcher. And after knowing that parameter or parametric function of some suppose of a certain study variables, that is one way is to survey the all elements, that is the census, and the second way to collect the only part of the population, that is the sample. So the survey, then the survey all units of the sample and get the all individual values of y, then we can get that kind of results. That is the population total, population mean, population variance, population standard deviation, population coefficient of variance. This kind of can be called the population, that is the census. But when we consider the thing like sample, then the things is not related with the parameter. First point is this. So when we go to the first look at this, when we go to the complete enumeration or the population study, that is each and census kind of study, that is we get the correct value of the parameter provided all informations given to you by the individual is correct. That means if this all y's are correct, it is given to you by the household, suppose in case of household survey, then this is the correct population total, then this is the correct population mean, kind of things. So in practice, in case of census, what we found, that is, it is a large scale survey, so non-response is unavailable. So someone is not interested to give you the response. So there is subjected to error. At the last of this lecture, I will come to how the error is dangerous, because that is a very, very important thing. So subject to error because respondents reports that is untrue values, and that is confidential characteristics regarding their income or age that they are not agree to disclose before the surveyor. So this is the error. So such error is known as non-sampling error, and we write it in the slide as NSE. So now look, what is interesting is that census is not only the fact where the NSE is or non-sampling error is there. It may be possible in case of sampling. It may be possible in case of sampling. So sampling thing is consists of non-sampling error, and in case of census there is also some part of that is non-sampling error. But Another error which is exist in sampling but not exist in census, that is a sampling error. What is the sampling error? That is your process of something, choosing the sample is wrong. That is, you are not correctly choose the correct individual for your information. Then this there is a chance of sampling error. But in case of census, there is no possibility of such error. So in case of sampling, there is two types of error. One is sampling error, possibility of. One is sampling error and another is non-sampling error. But in case of census, there is only non-sampling error because there is no sampling. All individuals have to be interacted. So after this, why we are going to census? Because the non-sampling error of the census, which is covering all in a particular units of the population, is so large, it is very, very greater than, I'm using two greater than type of symbol there. There is very, very greater than sampling error plus non-sampling error of sampling. So this is the thing that is why we are actually interested in case of sampling. So a sample that is identified, that is actually, look at this, this is our population, this Y is our population. Now from where I am choosing this sample. Sample is what? Sample is consist of small n number of units. Suppose there are small n number of units. Small n is very, very less than capital N. Suppose in case of a village there are 500 households and I'm choosing just 50 or 40 households from there. So 40 is the small n and 500 is the capital N. This is the fact. So which 40 will choose? That is depends upon the process. So going to that is this Y I1, this, that is, you just relate this, that is this I1, this I1 is anyone, this I1 is anyone among these Y's, anyone among these Y's. Then the thing is I2, that I2 may be anyone among these I's, not only this I1 is chosen, so it is subtracted, it may be subtracted, may not be subtracted, it may exist into the sample. That is the process. I will come to it. So that is sample is an ordered sequence, that is ordered sequence of elements from the population units, and it is identified as that small s, which is consist of I1, I2, and this I, what is the relationship between I and Y? No difference. That means this is the population character and that is chosen in our sample. So what is Y? Y is something that is selected into our sample, but the size are different. So this is the basic thing. For example, suppose 1, 2, 3, 4 be a population of size 4. Suppose there are the 4 individuals. Suppose there are 4 balls in a box, and you identify the boxes as 1, 2, 3, 4. They're putting the number on them. Now, putting the number on them, and then suppose you choose by this way, you choose the first ball you chooses, and then making it what number you have to it is come to you, that is you marking it as 1. Then you return it, then you choose it again, the first ball comes, so again you get the number 1, 1, and then again you return it, and again you choose the third ball, and the number 2 is come to you. So the sample is like this, 1, 1, 2. So this sample is called, this sample size is 3. But what is the, this is the sample size is 3. But what is important, that the effective sample size is 2, because one sample is repeated 2 times. For example, here the effective size is 2. Here also the effective size is 2. Here also the effective size is 2. But the different units are chosen. Here the effective size is 1. So these kind of things are there. These are the samples which are coming from some. This is my population. There is 1, 2, 3, 4. 4 balls are there. They are the marking kinds of things. So that is the probability or purposive sampling is that in probability sampling, a sample is selected according to a certain rule or method, which is known as sampling design, where actually each sample has some defined, that is pre-assigned probability. That is if this one is chosen here, if this one is chosen, one means first, that is one marking on a ball, and that ball is chosen, there is some particular probability of the ball coming into my sample, which is over which it is one is written there. So the probability of the sampling, that is very important. That is pre-assigned probability selections each and every population unit. So in case of probability sampling, we may define it as purposive sampling, and that purposive sampling is what? That is selection sample is subjective. It is not that is probability. Suppose my sample is this. I have to choose the sample this, that is which is only divided by 2. Suppose my sample is this. I have to choose 2 units from here which are only divided by 2. Then you have to choose only 2 or 4. So it is a purposive. That means you have some purpose. That is where you are choosing some numbers. It may be. Suppose, for example, you go to how I'm giving you with some socio-economic type of example. Suppose if you are moving into some villages, and where you are doing some work over the scheduled caste people. Then these scheduled caste households are there. Then the scheduled caste people, and you have to make some comparative study with the general caste. I'll come to the later. But the scheduled caste people, you have to select the scheduled caste households. That is the purposive. That is the subjective of your subject of your research. That is the probability reduces the probability of sampling reduces purposive sampling when the probability of selection of a particular sample is assigned as 1. That means it is always coming into in your sample. So the sampling design and the inclusion of probabilities, that is S is the collection. S is the collection. This S is the collection of all elements of the. It may be termed as population, and from where this symbol that is like E. This symbol means belongs to, and small s is the sample. That means this symbol signifies that is you choose the sample from the populations, and if it is a probability sampling, that probability of choosing small s, that probability of choosing small s is always non-negative. That means positive. That means there exists a particular probability of each and every population unit to come into a sample. This is the first rule of sampling design. And second rule is that by this way, if it is possible, how many probabilities we have to derive for such kinds of balls. Given example, I already given to you this example. So sum of all these probabilities is obviously equals to 1. So this 2 rule is very important. If there is probability based sampling, that is each and every individual probability must be non-negative. And the second property is called normed. It actually comes from the normalizations word, that is normed, N-O-R-M-E-D. So summation of probability is equals to 1. This is identified as normed. For example, in this example you follows, there is a population, finite population, which consisting of 4 units, 1, 2, 3, 4, and the samples are given to you. And suppose the respective probabilities of PS1 is 0.25, that means 1/4. Probability of PSP is 0.3, and probability is PS3 is 0.2, and PS4 is 0.2, and this way. These are the suppose individual probabilities, and these individual probabilities, that is inclusion probability of a particular unit into the sample from the population is defined by these particular probabilities. So inclusion probabilities are identified as that PS, or it may be identified as that is considering the joint selections or individual selections. It may be there. It is not very. That is, those who are not familiar with mathematics, I will not go to those complexities. So this is the way. That means a particular sample have some particular probabilities. So that is fixed and effective size design. For example, suppose that is in the given example. Suppose S1, S2, S3, S4, 4 samples are chosen, and the particular probabilities, and then from here, and we can find out the fixed sample size, that is FSS. We call it FSS, that is fixed sample size. And considering this example, That is, you can find out what is the probability of PS1 plus PS2. That is PS1 plus PS2. That is 0.25 plus 0.20. That is 0.45. If I choose these two samples, what is the probability that can be derived? What is the probability of second, third? What is the probability of first, third? These all can be derived. And considering this, considering this, the expected value. This is the expected value. That is each and every individual. From where it actually comes? It actually comes from here. That is this value into multiplied by this probability, this value multiplied by this probability, this value multiplied by this probability, and we calculate this value too. So if these expected values are derived for each and every sample, for example, here this multiplied into 0.3, this 2 into multiplied into 0.3, this 2 multiplied into 0.3, and for S3 this is 2, this 3 into 0.2, this 2 into 0.2. By this way, we calculate the VS and we find out the PS into VS. These are the for the calculation of the expected values, and this V square into PS that is useful for calculation of the variance kinds of things. That is a statistical calculation. Those who are doing with the social science research without considering this that is this kind of mathematical kind of things. I just tell you, don't concentrate it over these kinds of things. So there are two possible ways by which we can. Am I audible, or everything is okay to on?
Yes, sir.
Okay. So there are two possible ways that ensure the selected sample is representative, and one is random sample. Earlier we already discussed. That is, random sample means what? That is where the probability is attached. And the second one is non-random. So first we are concentrating on random sample, and non-random I will come later. So that is, selection unit in a sample from the population is governed by the law or chances of probability. So the probability of selection of a unit can be equal as well as unequal. So this non-random, in case of non-random, there is no such probability laws which is governing, and it depends by the personal judgment of the surveyor, the persons that is volunteering such kinds of medical test or to a drink or new type of coffee. There are some non-random laws. There may be, for example, you know the name of quota sampling. In case of survey, that is continued until a predetermined number of units or characters are picked up. That is, they are going to test such kind of surveys before the market, in the market of this kind of thing. Okay, I'll come to that non-random sample part later. So there is a simple random sampling, which we call SRS. It is a method of selections of sample. That is, suppose sample, we already tell you that it is sample is identified by small n, and the population is identified as capital N. So such small n number of sampling units out of the populations, which are capital N number of sampling units, have equal chances to come into the sample. That means what I'm telling you, suppose in a box there are 10 balls and you have to go to choose the 2 balls. So what you will do in case of simple random sampling, that is, each and every population unit have some particular chances to come into the population. Now the question is, there is equal chances is depending on two things. That is, that possible by two ways. What is the way? I choose a particular unit and then return it into the sample, a population. If it is done by me, that I choose a sample and mark its character, mark its variable, everything is marked, and after that marking, I may assign it or I may return it into the population. If I return it into the population, what will happen? Before each and every draw, the population size remains same. Okay, so this actually, there is some mistake. It is not. It is just read this. This is not SRSWR. This will be SRSWR, and this will be SRSWR. There is some mistake. Okay, so this is you read. This is SRSWR. That is called simple random sampling with replacement. That means before, suppose there are 10 balls in a box and you choose 3 balls. So you choose the first ball and mark its color. There are 10 different colors, suppose. So mark its color and then return the ball into the box. So since there are 10 balls in terms of the probability, how the probability is defined? Probability is defined as the ratio of in the denominator. There are that is total number of possible cases, and in the numerator, number of favorable cases. So there are total number of cases is what? 10 balls, among which I have to choose one ball. So in the denominator there is 10, and in the numerator I have to choose one ball. So 1 is there. So probability is 1 by 10. This is the definition of probability. So when I am going to choose a particular ball from 10 number of balls, what is the probability? 1 by 10. So here the population size is capital N. So the probability is 1 by capital N for each and every sample. If you choose the first ball, the probability is 1 by N. If you choose the second ball, the probability is same 1 by N, because there is a N number of balls. You return it into the population. Population size remains same. So by this way, if you continue it up to suppose 10 times, so what will happen? 1 by N into 1 by N into 1 by N up to 10 times, that is 1 by N to the power 10. And since we are considering that our sample size is small n, so it is continued up to small n times, and the probability is 1 by capital N to the power small n. So this is the simple thing. This is these things define that this is the probability of a particular unit chosen from the population, and this is identified that this is the probability of choosing a sample, that is 1 by N to the power n. In case of SRS, WR, not WR, that is with replacement. But if it is done that the population is choosing without replacement, in case of without replacement, what will happen? That is before every choice, the population size will be reduced. So population size will be reduced. So what will happen? What is the, suppose in case of considering that example, there is 10 number of balls. In case of first ball, the probability is 1 by 10. In case of second ball, it is 1 by 9. In case of third ball, it is 1 by 8. So it is reducing. So we can identify the probability by this way, that is choosing a particular number of units. If the ith unit is not selected from the first k-1 draws, that is if it is selected, I keep it aside, not returning it to the populations. So the probability is identified as 1 by N minus k-1. If the ith unit is not selected from the first k-1 draws, that means what is pk? pk is that probability that before which k-1 draws are already occurred. So the kth draw, if I am consider the fifth draw, what is the probability? 1 by N minus 5 minus 1, that is 4. That is what is happening in fourth draw. That cases will be subtracted. So by this way, if it is continued up to small n times, so first unit probability is identified as 1 by capital N. Second unit is what? 1 by N minus 1. Third is what? 1 by N minus 2. By this way multiplied up to its nth. So look, in case of second it is N minus 1. In case of third it is N minus 2. So in case of N it will be N minus 1, and since there is a minus, so this minus becomes plus. So that is N minus N plus 1. So the total things is this in case of, and we write it in the symbol, that is combinations notations, that is 1 by N minus N. So this is the way we have to write the things. That is in case of simple random sampling without replacement, the probability when you not return, suppose you choose a household and identify its character, identify your research questions from that household and separated it. If you return it, that is the process. That is also a process. That is the process of replacement. But if you not return it into the population, you separated it, you cannot go further again to that households. Then it is the case of SRS WOR. So I'm giving you one example for better understanding. That is suppose the population units are considering like this. That is population is 2, 3, 4, 5. These 4 numbers are there. So what is my population mean? What is my population mean? It is a very simple mathematics, not a very complex one. So what is the population mean? That is 2 plus 3 plus 4 plus 5 divided by 4. Why 4? Because 4 numbers are there and the average value is 3.5. So this is the population mean. What is the population variance? When you calculate the variance, we subtract this mean value, that is 3.5, from each and every value, that is from 2, from 3, from 4, and from 5, and making their square. So this thing comes. Look at this, and that will divide by 4, and I find the value is 1.25. This is the population variances. So population mean and population variance, suppose these are the two characters, and these are called parameter. These are called parameter. These characters are called parameter. But I am choosing a sample from this population, suppose 2, 3, 4, 5. You may identify these 2, 3, 4, 5 as separate households or separate students in case of education survey, separate diseased, aged persons for health survey. You may choose this by this way. So if I am returning this, that is SRS with replacement, simple ensemble with replacement, what are the possible samples? We found there are 16 possible samples. What are these? That is, first 2 is chosen, and I return the 2, and again 2 is chosen. So it is the 2 is the combination. It may be 2 3, it may be 2 4, it may be 2 5, it may be 3 2, it may be 3 3, it may be 3 4. By this way, look at the possible combinations. It is last at 5 5. So these are the possible sample values. And what are the mean? I just calculate their mean. That is 2.2 plus 2 divided by 2, that is 2. 2 plus 3 divided by 2, that is 2.5. So each and every cases I calculated, estimate the sample mean. So look, population mean is a constant, that is fixed. But sample mean is a variable. This is the difference. That means it varies. So if I summarize this table, that is considering the mean values. What are the population different mean values? Values are 2, 2.5, 3, 3.5, then 4, then 3.5, sorry, then 3.53, then 4, then 4.5, and then 5. So if I consider, this is actually not 3.53, this will probably, this will be mistakenly this happened, this will be 3.5. So the values, what are the sample mean values? I arrange this. These are the sample mean values. Now what is the sample? What is the frequency of 2? I found 2 is happening in 1 times. In these 16 cases, 2 is happening only here. So I put the frequency of 2 is 1. What is the frequency of 2.5? I found that 2.5 is happening here. Look here and here also. Look here also. So the 2.5 frequency is 2. By this way, I calculate the frequencies. That is sum of which is total 16. So what is the probability? Probability is now the total favorable cases divided by total cases. What is the favorable cases of 2? That is 1. What is the total cases? That is 16. So it is 1 by 16. It is 2 by 16. It is 3 by 16. 4 by 16. By this way, you can calculate the probability. So what are the probabilities of each and every sample mean? This can be determined from here. So now I found out the mean of the sample means. That means these are the sample mean. These are the sample mean. What are the mean of these sample means? So if I find out this, if I try to get this, then what I'm using, that is this 2 multiplied by 1 by 16, 2.5 multiplied by 2 by 16, but 3 multiplied by 3 by 16. So by this way, I estimate the values is 3.5. So look at this value, that is 3.5. That is the mean of the sample means, and that is equals to the population mean. This is the interesting thing. That is equals to the population mean. So the population mean, that means if I choose in case of SRSW W with replacement, we found that if I choose the sample and there are the different means, and if I find out that suppose I found mean as a character, then if I find out the mean of the sample means, then I found the population sample mean of the sample means is equal to population mean. But what is happening? That is, if I considering these values as x, and this is the probability, by the sample value same as population calculation, if I calculate the variances, that value becomes 6.25. But here, look, the values is 1.25. So population variance is not represented from the sample, but population mean is represented from the sample. This is a very, very important property. So what is our observation? observation is this: the mean of the sample mean is the population mean, but the variance of the sample mean is not equal to the population variance in case of SRSWR. And there is a mathematical proof, and I'm not going to that mathematical proof because this understanding is quite better, because so many people are not from statistics or mathematics background. They can do this without making such kinds of calculations. So so these kind of things are actually happening. That is in case of SRSWR, we found that that is each and every population unit which are chosen are independent, because it is not influenced. But in case of what is the difference between simple random sampling with replacement and without replacement is that simple random sampling with replacement, when I am choosing one particular unit and then what I'm doing, I return it into the sample. So my second choice is not influenced by my first choice. It's not dependent on my first choice. So why I am calling that each and every units are independent to each other. That means one choice of one thing is not depend on the other. So this is the but in case of without replacement, if you go to any simple statistic book, you find there this type of calculations. This for your better understanding what is the methods behind such things. In case of SRSWR, suppose there are 10 balls, and of which 4 are green, 5 are red, and 1 is black. Now, if I am choosing one ball, and if I found it is red and I separate it, number of red ball into the box is also reduces as with the total number of ball. So, what is the color of the first ball? The second ball choice of second ball depends on that. In case of SRSWR, when I am not replacing the ball, then my choice depends on my choice depends on my previous choice. In case of SRSWR, that is happening. So that is I am showing to you from this example. It makes also easy to you. This is where it is. Yes, this is my population, and this is given to you that this is the population mean and this is the population variance. Now I am following SRSWR. That is without replacement. So what is happening? I choose the 2, then not return it. So next one is 3, or next one is 4, or next one is 5. So there are the 3 samples. If I choose 3, then 2 is not possible because 2 combination is already there. 2, 3 or 3, 2 is there. So I have to choose 3, 4, or it may be 5. If my first choice is 4, then 4, 3 and 4, 2 is not possible because they are already there. So 4, 5. So these are the samples in case of without replacement, when I am not replacing. So look, earlier there are 16 cases possible. Now only in case of SRSWR, only 6 cases are possible. So if you find out the sample mean under these cases, that is 2 and 3, that is 2.5. 2 plus 4, 6 divided by 2, that is 3. By this way, if you find out the sample mean, and by the same thing, I arrange the sample mean values and find out the frequency. Only it is 2 because 2 times it is occurred. Everyone is 1, so totally 6. So you find out the mean of the sample means again. That is 2.5 into 1 by 6, 3 into 1 by 6, 3.5 into 2 by 6. By this way, if you do the calculation, the value is same. That is the population mean. So everywhere, in case of SRSWR or SRSWR, that means in case of with replacement or without replacement, mean of sample mean is always equals to population mean. That means it is a true representative of the population character. mean is such a good thing. So, but in variance, it becomes again, if I estimate this, the variance is not equals to 1.25 because population variance earlier derived by us is 1.25, this value. And here also in case of SRSWR and WR, we found in case of WR it is 6.25, and in case of WR it becomes 0.4167. So this observation also gives the mean of the sample mean is the population mean, but the variance of the sample mean is not equal to the population in case of SRSWR. In case of without replacement, this thing is happening. So This is the kind of things, and that is in case of in case of sampling designs, such estimates like that is we want to calculate the population picture like the mean or like the variance. These values we have to estimate from the particular. That is one of the main objectives after selection of the sample, is to know about the tendency of the data to cluster around the central value, or the scatteredness of the data around the central value. So among various indicators of central tendency and dispersions, the popular choice like arithmetic mean and variance. So the population mean and population variability are generally measured by the arithmetic mean or variance. So there are various various important or significant estimators for estimating such kind of things like population mean or variance. Among them, simple arithmetic mean, it may be geometric arithmetic mean, it may be harmonic mean, and simple, and in case of sample also, sample variances we estimate. Now, so one of the reasons of these estimators is that they possesses the nice statistical properties. So they also that is obtained through the self-established statistical estimation procedure like maximum likelihood estimations, least square estimation, method of moments. They're the different processes, and one may consider other indicators like median, mode, geometric mean. What I'm telling, there is a different measures of central tendency, or the measure instead of variance, mean deviation, absolute deviation, Pitman nearness, etc., for measuring the dispersions. So, what properties of such estimator can be studied by the numerical procedure? These are called something in computer. Those who are working with the languages, these are called bootstrapping. These are called bootstrapping. In case of SLSWR and SLSWR, with the help of statistical algebra, what he found that the mean of the sample mean is equals to the population mean, and sample variance for the sample variance, this property is not holding. This property is called biasness or unbiasedness. That means when the sample mean of the sample mean is equals to population mean, then we can say that the sample mean is an unbiased estimator of the population. But sample variance is not an unbiased estimator; it is a biased estimator. So if I identify suppose theta as a population character and t as a sample character, suppose t and theta are the two things, then if expectation of t is equal to theta, that means mean of the sample values is equals to population values. These kinds of unbiasedness is actually meaningful. Those who are interested, they can go. So the standard errors of sample mean means the standard deviation of the sampling distribution. So if it is asked to you any interview, what is standard error? You may answer by this. It is nothing but a standard deviation, but not standard deviation in what sense we are using statistics. It is the standard deviation of the sampling distribution of a statistic, not the parameter. It is the standard deviation of the sampling distribution of a statistic. So standard error is a statistical name that measures the correctness in the sample represented of population, because to know the feature of standard error is very important. Those of you in future you go to test your research hypothesis, they are the t values, then you have to, what is the t values, that is beta hat minus beta y standard error. So that standard error is here. That standard, if the standard error is large, then the t value is low, then the chances of to get the null hypothesis corrected becomes easy. So these kind of things will be there. So standard errors, it measures the correctness in which the sample represents a population, and it is actually what, that is the sample mean deviates from the real population mean. That is the deviation is standard error. And the term is standard error is used to denote the standard deviation of variety of sample statistics, such as it may be used for mean, it may be used for median, it may be used for mode, this kind of thing. So standard error of mean refers to standard deviation of the distribution of the sample mean. Smaller the standard error, it means more representative the sample in compared to the whole population. So standard error is also a counter that is proportional to the sample size. Larger the sample size, smaller will be the standard error, because the statistic will advance the real value. And the standard error is considered as a major part of really the discrete statistics. It represents standard deviations of mean within the data set. So it provides as a measure of variation of random variables. That is, providing a measurement of spread. That is, smaller the spread, more true, more accurate the data set is. So standard error and population sampling, that is move the data, and how the standard deviation and standard error are related. Standard deviation is a gross concept, but standard error is the standard deviation of a sampling distribution of a statistic. That means it is related with the sample part. Now, the simple random sampling scheme provides a random sample where every unit of population has a particular probability of selection. So, under certain circumstances, it is found that more efficient estimators are obtained by unequal probabilities rather than equal probabilities. So, this type of sampling is known as varying probability sampling. And this type of sampling is the varying probability sampling. If y is a variable, for example, in our study, suppose it is the age, and x is an auxiliary variable related to y. Suppose x is a auxiliary variable, means it is suppose the age of the father, and then y is the most commonly used as a varying probability scheme. That means the units are selected with probability proportional to the value of x is called the size. So the term probability proportional to a given measure size, we call it PPS sampling. And if the sampling units are very considerable in size, the simple random sampling does not take into account the possible importance because of the larger units of populations. So as the unit with a large values of y that contributes more to the population, so it is natural to expect that the selection scheme which assigns more probability of inclusions. So this accomplishes through the probability proportion to sampling, and in case of the probability of selection of a unit will not change, and the probability of selecting unit is specified unit at the same remains same at any stage. So no redistribution of the probabilities after drop. And selection of units without replacement in case of PPS also you can apply the SRSWR and SRSWR. So this is all about what I am discussed. That is related to simple random sampling. How much time we can next we have? Up to 5:15, na?
No, sir. Within 5, maximum 5.
Okay. So we have to make some hurry. That is, next we go to another type of sampling, that is systematic sampling. In systematic sampling, what is happening? The first unit is selected by using random number, and the remaining units are selected by predetermined pattern. That is systematic sampling is very convenient in selection of sample, and here we used extensively in most practicals. For example, linear systematic sampling. Suppose sample size is small n and the population size is capital N, and first unit is selected, suppose R, at random from 1 to k. So you divide your sample size, you divide your population by the size of the sample, and then you suppose 100 households are there, and you have to choose 10 households. So what you are doing, you divided the 100 household by 10 households, you get the 10 that is 10th interval. You get one interval consisting of 10 households, and that is identified here as a k. And that k, from kth you choose the first, suppose third, from the first bracket you choose the third one. Then from the second bracket, you have to choose the third one. Then from the fourth bracket, you have to choose the third one. By this way, you are going. This is the systematic sampling, and there it is not very difficult. But one problem, if it is not an integer. Normally, what we are doing, we make it an integer. If it is not an integer, is what sense it is closed. Then we consider this. For example, if it is an integer, then it is okay. That is suppose the sample units are 1, 4, 7, 10, and the probability of this sample is 1/3, and second sample is 2, 5, 8, 11, and the probability is from the natural numbers. And probability is this. Then the 3, 6, 9, 10. So look at the pattern. First unit it is 1. First unit it is 1 is chosen. In the second it is second, and it is third. And the second unit is fourth. Here the second unit is fifth. That is here the second unit is sixth. Then seventh it is 8th. It is 9th. Then 10th, 11th, 12th. By this way we are going. So after make the division, this is the possible. And in case of if it is not an integer, what we are doing? That is in case of that is suppose a capital N is 13. I am giving one example, and the sample size is 4. So it is 3 point something, but we consider approximately it's 3, but it may be extended to 4 once. Suppose for example it is 1, that is 2, then it is 3, then it is 4, then it is 5, then it is 6, then it is 7. Then it is 8, then it is 9, then it is 10, then it is 11, then it is 12, then the only one unit is there, suppose it is the population. That is 13. That is included into the first sample. So by this way, the sampling choice of sampling is going on. If it is an integer and if it is not integer. This is the basic thing of what we call, that is the systematic sampling. So next one is most important, that is the stratified. The efficiency of an estimator can be increased by increasing the sample size. So it is not wise to select a sample from large population at a time because it will representative in the sense that the sample unit may be distributed evenly or unevenly over the population. So the efficiency can also be increased by greatly dividing the population into homogeneous group. That is in different layers, in different strata. Then the selecting samples from each group separately. So what is the basic objective of the stratified sampling? That is I have already told you, that is the efficiency. Also we can increase our efficiency in case of sample selection, that is by dividing the population into homogeneous groups. That is dividing in terms of the different layers of strata and then selecting the samples in the different groups. So stratified sampling is commonly used in case of large surveys. So in stratified sampling, what we are doing, populations, suppose it is a population size is capital N, it is divided into the mutually exclusive or exhaustive groups are called strata, and from the particular one strata, particular one unit is chosen for the samples. From each of these strata, samples of the suitable sizes are selected independently by some suitable sampling. For example, suppose in case of the household survey, you divided the heterogeneous population of different castes, because population you are dividing in terms of caste. So there is general caste people, there are the SC people, there are the ST people, there are the OBC A people, OBC B people, different criteria people are there. So now on the basis of the caste criteria, you divide the population into different strata. So from the strata, you have to choose from each strata, you have to choose your particular identified sample. So sampling procedure of different strata need not be the same. It may be depend on the available information about the respective strata. For example, we want to select a sample of 50,000 households from Birbhum to estimate the local number of unemployed persons, suppose. So in these situations, one may divide the Birbhum into few mutually exclusive and exhaustive zones, such as blocks, for example, blocks. And from each block, sample of the household may be selected independently. Suppose further, the number of unemployed persons in the households of the same block is available from past surveys, and then using that is auxiliary this information as an auxiliary variable, one can select sample by using the inclusion probability proportional to size to the sampling proportional into the strata, where the auxiliary variable is available. And thus for each strata, that is thus for each stratified sampling, we must be careful. We must be careful about the problem of forming the strata and its number. There is the sampling procedure of different strata and allocation of sample size of the respective strata. So the basic idea behind the stratified sampling is that divide the whole heterogeneous population into the smaller group of subpopulations such that the sampling units are homogeneous with respect to the characteristics under study within the subpopulation. And number two is this, that is heterogeneous with respect to the characteristics under the study between or among the subpopulations. Such subpopulation are termed as strata, and treat each subpopulation as a separate population and draw a sample by SRS from such strata. So what are the advantages? What are the advantages of this stratified kind of things? That is estimation of subpopulations, which is estimate the population characteristics that are needed not only for the entire population but also for the different subpopulations. Once you treat such subpopulation as strata. For example, a national unemployment survey, the government may be interested to estimating the unemployment figures for the entire country. So as well as for the state also. So in this case, each provinces are taken as a strata. And second one is the administrative convenience. So the for example, the agency which conducts the survey just 1 minute. The agency which conduct the survey may stratify the population such that the survey may be supervised in an efficient manner. So agency can appoint separate supervisor to conduct such a kind of each strata separately. So that is the administrative convenience. Representativeness of the sample, that is in stratified sampling, formation of strata and allocation of samples to the different strata may be done in such a way that the sample can represent the population with respect to the characteristic under study. For instance, if we want to select a sample of students from school, which are represents of different race in the area, a simple random sampling without replacement sample from the entire school may not be representative. In this situation, a stratified sampling using different racial groups as a strata is expected. And next one is the efficiency, that is stratification may increase the efficiency of the estimates by forming strata in such a way that each strata becomes homogeneous with respect to the characteristics of your study. That is suitable sampling schemes to the representative strata may increase efficiencies of the estimators and improve quality of data. Obviously, this is the most important part, because if all these four above mentioned points are true, then the fifth one, that is obviously the quality of the data should increase. That is, it obtained employing different types of investigations to different strata. And investigators knowing local languages may be deployed to the rural areas, whereas in urban areas, investigators are using English. These are the advantages. These are the advantages of this kind of strata sampling. So there is also an estimation procedure. I'm not going for the time deficiency because I'm not going to the mathematical kinds of things of such estimation process. Rather we are going to the that is known as cluster sampling. So what is cluster sampling? Cluster sampling, I'm giving one example. Suppose you want to select a sample of 2000 HS students from all HS students in a particular district to estimate the average cost of education. So in this case, if we use simple random sampling with replacement or without replacement or systematic sampling for selecting the sample, we first record the sampling frame that comprises a list of all HS students in that district. So it is in most situations such list is not readily available. So we can then look for the list of the schools in that offer HS program in that districts. Such a list is much easier to obtain, and we may select the sample of schools instead of students, instead of selecting the students directly. And then survey of all HS students of the selected school. This type of sampling procedure is called cluster sampling. This is the thing. So technically, a group of units is called cluster, And each unit in a cluster is called the ultimate unit, from which the statistical information is to be collected. And one of the basic assumptions in this sampling procedure that population can be divided into finite number of distinct and identifiable units. That is the sampling units. So the smallest the units into which the population can be divided for the elements, and the group of such element is called clusters. This is the cluster sampling. So many practical situations and many in many types of population, list of elements is not available. So to use this, use such an element of sampling unit is not feasible. The method of cluster sampling area, that is cluster sampling, can be used under such situations. So in cluster sampling, what we are doing, that is we are divide the whole population into clusters according to well-defined rule. There must be some well-defined rule. Treat the cluster as sampling units. Choose a sample of clusters according to some procedure. Carry out the complete enumeration of the selected clusters, that is collect informations on all the sampling units available in selected clusters. And then we select the sample of cluster by some suitable methodology of SRSWR or SRS. That means look after the thing, that is SRSWR and SRSWR. These are the basic requirements. From this basic you can calculate the things, because the method of such kind of cluster sampling is cheaper, easier, and operationally convenient, because units within the same cluster are generally located close to each other. That is the most advantage. And traveling costs, this kind of things are much less than the other sampling procedures. So as far efficiency is concerned, cluster sampling is generally not so much efficient except in case of some geographical studies, and they are using the cluster sampling. So next one is the area sampling. That is entire area containing the population is subdivided into smaller area segments. And for example, you may know that is in case of our just we passed our that kind of experience regarding the lockdown of the section of the city. That is this area, the cases are so prominent. So this kind of things are there. So in that case, the area sampling, that is the total population is subdivided into small area segments, and each elements into the population is associated with one, and one of such segment is the procedure is called area sampling. That is individual persons staying in the houses may be difficult to obtain or even may not be available, but the list of the houses may not be within the city is not available. So under that case, such kinds of area sampling we can use. These are the things, and the next one is the multi-stage sampling. Normally we are in case of our real life, that is we are using such kinds of sampling. That is in cluster sampling, the entire population is divided into mutually exclusive and exhaustive group called cluster. So each cluster consists of several ultimate units. In a sample, clusters is chosen by some suitable sampling scheme. And in case of two-stage sampling, clusters are termed as the first stage primary sampling units. The ultimate units are clusters are called the second stage. By this way, that is different stages. That means it is multi-stage is nothing but it is a combinations of different kind of sampling within its particular how many stages are there. That means, for example, those who are doing the socio-economic survey as per their requirement, and then they go to the first, suppose in case of suppose the study over the West Bengal. So which district you have to choose, that is first stage. In the second stage, suppose these districts are chosen. Now which blocks you have to choose, then or before that you may choose the subdivisions, and then from there those subdivision which blocks, and then from the blocks you get the list of the villages, and from which villages you have to make the survey. See, these are the examples of multi-stage, and each and every stage you can use either the simple random sampling or the stratified or the clusters, this kind of sampling. So now we have the time to go to the non-probability kind of sampling. So non-probability sampling is one associated with the case of research designing and quality research also. So With regards to the qualitative research, case studies that is tends to focus on small samples are intended to examine the real life phenomenon. That is not to make the statistical inference in relation to wider population. There actually this kind of sample is uses. A sample of participants or cases does not need to be representative or random, but a clear rationale is needed to inclusion of the cases. For example, in case of quota sampling, quota is a non-random sampling technique in which the participants are chosen on the basis of predetermined some characteristics. So the total sample will have the equal or same distribution of characteristics as wider population. So quota sampling, researcher selects people, that is in some non-random basis according to some predetermined quota. So two types of quota sampling are proportional and non-proportional. Proportional quota sampling, the researchers wants to represent the main characteristics of the population by sampling a proportional quantity to each. There may be several examples. I'm not going to those kind of things. And non-proportional is a bit of unrestricted kind of things. In this technique, non-proportional, the researcher specifies the minimum number of sample units are already. That means according to his research design, he fixed that this number is okay for me. That means I'm not going to the many individuals. I'll select only 2 or 3 number of individuals and survey them extensively as per my purpose. So these are the methods of non-probabilistic analogs of stratified random sampling, and that is characteristically used in reassure the smaller groups are sufficiently represented in this sample by this pair. So next one is snowball sampling. This is quite interesting. That is it is a non-random, and that is few cases help encourage the other cases. For example, those who are working on drug addicts, then what they do, they identified by any way anyone drug addict and interact them by considering that drug addict next person they targeted by getting the information from that addicted person. So this is the way, that is they are collecting one information, and from that information they collect the information for the next unit, and from that next unit they go to the next unit. By this way it is moving like a snowball. When it is coming from upper to the lower, it becomes bigger and bigger. So this approach is most applicable in small populations that are difficult to access, and due to the closed nature, for example, secret societies, inaccessible professions, and the researcher begins by identifying someone who meets the criteria to be included in the study. Then he asks them to purpose of the others who they know and who also meet this criterion, and from where. This kind of sampling is helpful when the researcher is trying to attain the population that are unreachable or tough to find. This is the snowball sampling. For example, studying the homeless, you are not likely to be able to find a good list of homeless people with a specific geographical area. And researcher about I'm telling you the drug addicts, and there is another, that is the convenience kind of convenience sampling. That is convenience sampling is selecting the participants because they are often readily and easily available. That is convenience sampling tends to be favored sampling techniques among the students, and it is inexpensive and easy options, and in compared to other sampling techniques. And there is also heterogeneity sampling. That is we sample the heterogeneity when we want to incorporate all opinions of views, and we are not concerned about the representing the views proportionality. So another term for this sampling is there are the varieties also. So there is non-sampling errors, and I am telling earlier you that what is the basis of the non-sampling errors. That is lack of proper specification, and incomplete coverage, faulty definition, defective methods of data collection, tabulation errors, data specifications due to methods of interview and observations of collection is inaccurate. These kind of things are the major parts of the non-sampling errors. And sampling error is square of sampling bias, sampling variances. I discussed this. That is what is the biasness, that is mean mean of some sample mean is equals to population mean, but mean of sample variance is not equals to the population. That is the generation of such kind of things. So after getting this, Warner is a statistician. He introduced the randomized response techniques, and that is estimating the proportion of a unit in a population positing a certain stigmatized character. For example, HIV infection status. There the sample method, that is simple random sampling with replacement procedure, and he found that process he defined, that is quite modern procedure, that is known as randomized response. That is you took a individual randomly, and what response you collect from him, and there is nothing is pre-designed or this kind of things. So these are the very modern kinds of things. And after that I will not get to cover these kinds of things. Yeah. So regarding this kind of things, actually, when we are discussing the distribution of a particular, that is, suppose you are going to plan to that is taking informations from the individuals on the basis of your choice. And there you are concerning that whether the variables about which you are interested is a continuous variable or a discrete variable. So that means we are doing there are two types of probabilities. One is called probability mass function, and it is called probability density functions. And the specific variable with which you, suppose for example you are considering with monthly per capita consumption expenditure. This is an economic variable. Or you may consider the minimum variation, the minimum temperature in a particular district, variation of rainfall in a particular district. So if you consider this variable, you have to follow the distribution pattern of the variable. So it is very important for us before going to the sample, before take to the sample, that what is the distribution pattern. There are so many statistical distribution pattern are there. Without knowing the distribution pattern, you cannot do the work that is whether it is hypergeometric or binomial or Poisson, this kind of things. So the relationship between the variables is very important to us, and the relationship one variable, you know, everyone, that is one variable is called independent, and another variable is called dependent. For example, in this equation, I'm just writing here, that is y is equal to 1200 plus 200x plus x square. So you find x is the independent variable and y is the dependent variable. And suppose this x is like a student get the Konyasri scholarship amount, and y is the variable that is identified of that scholarship, what portion he spends for data recharge to attend the online classes. So if this is the situation, suppose this is an equation I fitted, that is 1200 plus 200x plus x square. You may not consider that factor x square. There is only suppose 200x. So if you get some in the student's information on the basis of this equation, and if you get the x as the amount of the scholarship what she get from Konyasri, and y is what she's paying for data recharge for attending the online classes. Now this is the thing. So this is the equation. This is the equation stating the relationship between the variables. Now suppose what is happening, that is he spends, suppose his Konyasri amounts is suppose in a month it is 1200, so suppose 1500, and about from this 1500 he spends 500 on data recharge, and 1000 in remaining other purpose. That is not, we are not interested. So this is 50, the x value is 1500 and the y value is 500 for one student, and for another student it is different. So on the basis of these informations we can construct some study. Now this is okay. Now suppose within this time frame you are aware about the platform like Netflix or Amazon, there is a new film like Family Mission 2 that will released. So what that particular students will do, that is, in that time when the Family Season 2 is released in Amazon, then what she is doing, that he makes another 200 rupees extra data recharge. So that relationship is not actually explained by this equation, that is y is equal to 1200 plus 200x plus x squared. Because here if x is what and what is y, you can get from this relation. But if it is what is the influence of releasing the film like Amazon platform or Netflix platform, if it is releases some new film there, how the data recharge is varied, that is not explained here. So the actual relationship, we have to write it in this way. That is, there are some unobserved part. So if it is found that the Scholastic scholarship is spent on part of the Scholastic scholarship is spent on data recharge only for online classes, it is not happening. There are some other factors also. So in case of sampling also, that is in case of sampling also, you find that is when you are going to choose the variables, then there are some other influences also that will influences our daily life. So before knowing that is which particular things is that, so you have to know the proper distributional pattern. That means how it is distributed. That means this variable u you have to identify before going to choose the sample. You have to identify this, that is this influencing factor, these unobservable facts. In case of econometrics, we call this as error, or that is noise variables. These kinds of, there are different names. So you may I'm telling you this type of relationship. This is a purely a nonlinear relationship. There may be different types of relationship, and in those cases, the role of u, that is the unobserved part, is very important. If the relationship looks like this, that is in the first form, that is beta 1 plus beta 2 into 1 by xi, this is called reciprocal. And if it is yi is equal to beta 1 plus beta 2 log xi, this is called semi-logarithmic. Those who are from the economics or anthropology or statistics or from that is sociology, if they are applying some quantitative relations, then before going to the sampling, what I'm telling you, that is, you have to construct your model. That these are the examples of the different modelings what we are normally used. That is logic model is also there, and inverse reciprocal is also there, double logarithmic is also there. And this you have to construct this modeling. That is, what is the actual relationship between your dependent and independent variable, making some idea about such relationship in prior before go to the sample, and making some idea what are the unobservable factors which can influence the answers of the interviewee into the sample. Okay, so today I will stop here. I think I do not know.